Today we're going to talk about the introduction to the gases and gas laws. We're going to review the kinetic molecular theory and talk about Boyle's law. We are not going to talk about Charles's law today. First, the kinetic molecular theory. A gas consists of very small particles, each of which has a mass. The volume of the gas particles is assumed to be zero. Gas particles are in constant rapid random motion, and that the average kinetic energy, how fast they move, of a gas particles depends on the temperature of the gas. High temperature equals a higher kinetic energy, lower temperatures equals a lower kinetic energy. And then last, gas particles exert no force on one another. They collide and bounce around, but there is no true force exerted. Okay, we're going to talk about the units that we use when dealing with the gas laws. So for pressure, there are 4 different types of units that we can use. We can use millimeters of mercury. We can use atmospheric pressure. These are the 2 you're most likely going to see. We can always also use pascals. And you will also see PSI. PSI may be the one you're most familiar with, pounds per square inch. That is the unit we use in our tires. Millimeters of mercury is what they use, the units that they use when doing our blood pressure. But the 2 for our gas laws that we will use are millimeters of mercury and atmospheric pressure. Temperature. Celsius is given in terms of C. That is the one we use the most often in science in general. Fahrenheit is what we see in our usual weather forecast, general day-to-day. We don't use that in science. And then Kelvin. Kelvin is another unit that we use in science. And it is our primary unit for our standard unit for gas laws. Kelvin, 1 degree Kelvin is equal to the Celsius plus 273. So if you had a Celsius reading of 32 degrees plus 273, that would be 310 degrees Kelvin. So the one that we will use in our gas laws is Kelvin. So anytime something's given to you in Celsius, you add 273 to it. Volume. The 2 units we use for volume in the gas laws is milliliters and liters. 1 liter equals 1,000 milliliters. The only thing you have to be careful with in this is that your units have to be the same on both sides of your equation. So anything that's talking about the volume in your equation must be in the same units. Okay, STP stands for standard temperature and pressure. So in the gas laws, when we talk about standard temperature, it is equal to 0 degrees Celsius, but remember we're not using Celsius in the gas laws, so 273 degrees Kelvin. Our standard pressure is 1 atm or 760 millimeters of mercury or 100 and 101.3 kilopascals or 14.7 psi. Boyle's law states that for a fixed amount of an ideal gas kept at a fixed constant temperature, the pressure and the volume are inversely proportional. So what does that mean? That tells us that as one goes up, the other one goes down. So in this case, as pressure increases, so as our pressure is increasing this way, our volume is going down. Then the volume goes down. And conversely, as our pressure increases or decreases, as our pressure decreases, our volume goes up. So that's what it means to be inversely proportional. As one goes up, the other goes down. So the formula for Boyle's law is P1 times volume 1, our pressure 1 times our volume 1, is equal to our ending pressure times our ending volume. So P1 is starting pressure, V1 is our starting volume, P2 is our ending pressure, and V2 is our ending volume. Okay, so if we're going to try and solve for our starting pressure, then what we need to do in our equation is we need to isolate our P1. And we do that by dividing both sides by V1. So that our equation becomes P1 equals P2 times V2 divided by V1. If we are solving for V1, we need to isolate V1. And again, we want to isolate V1, so we divide both sides by P1. And so our equation becomes V1 is equal to P2 times V2 divided by P1. If we are solving for P2, we're isolating P2, so we need to divide both sides by V2. V2's cancel out, so we wind up with P2 is equal to P1 V1 divided by V2. And lastly, we're trying to solve for our ending volume, then We're isolating for our ending volume. So we need to divide both sides by P2. And our formula becomes V2 is equal to P1 times V1 divided by P2. Okay, a couple of practice problems. The first one, a gas occupies 12.3 liters at a pressure of 40 millimeters of mercury. What is the volume when the pressure is increased to 60 millimeters of mercury? Okay, so our knowns, it occupies 12.3 liters at a pressure of 40 millimeters of mercury. So we start with 12.3 liters and 40 millimeters of mercury. And the question is, what is the volume? So our volume is our unknown. When the pressure is increased to 60 millimeters of mercury. Okay, so our formula, we are looking for V2. And if you refer back to the notes from just a second ago, V2, if we're looking for V2, it is P1 times V1 divided by P2. So this should set up where we have 40 millimeters of mercury times 12.3 liters divided by 60 millimeters of mercury. So millimeters of mercury will cancel out. And when we plug that into our calculator, our V2 is equal to 8.2 liters. So solving for V2, our initial pressure, which was 40, times our initial volume, which was 12.3, divided by our ending pressure of 60 millimeters of mercury. And that means our ending volume was 8.2 liters. Okay, a second practice problem. A gas occupies 11.2 liters at 0.86 atm. What is the pressure? So pressure is our unknown if the volume is 15 liters. So our pressure 1 is 0.86 atm. Our volume 1 is 11.2 liters. Our ending pressure is our unknown, and our ending volume is 15 liters. So our formula, P2 is equal to P1 times V1 divided by V2. So P1 was 0.86 atm times 11.2 liters divided by 15 liters. Plug this into our calculator, 0.86 times 11.2 divided by 15 is going to be 0.64, 0.64 atm. Liters cancel out, so atm is all that's left as our units. practice problem 3. We have P1, V1, P2, and V2. A sample of oxygen gas occupies a volume of 365.2 milliliters. When the volume is increased, so now our volume is changing, so this is our second, to 478.2 mils, the new pressure, so new pressure, that tells me that's the P2, is 0.318. So this is V1, V2, P2. What was the original pressure? This is our unknown. So P1 is unknown. V1 we said was 365 milliliters. Our second pressure was 0.318 ATMs. And our second volume was 478.2 milliliters. So our formula, P1 is equal to P2 times V2 divided by V1. Plug in our numbers and we get P1 is equal to P2, which is 0.318 ATMs, times 478.2 milliliters, our V2, divided by our V1, which is 365.2 milliliters. Milliliters cancel out. Plug the numbers into the calculator, and you should come up with a P1 of 0.42 ATMs. 0.42 ATMs. Okay, so for our fourth example, we have a sample of chlorine gas that is held at a pressure of 1,023 millimeters of mercury. When the pressure is decreased to 811.4 millimeters of mercury, the volume is 25.6. So we started with 1 and we went to a second. So this is our P1. This is our P2. So this is our V2. And it wants to know what is the original volume. So our P1 was 1,023.6. Our V1 is our unknown. Our P2 is 811.4 millimeters of mercury. And our ending volume was 12.6 liters. So our formula for V1 is P2 times V2 divided by P1. So V1 is equal to 811.4 millimeters of mercury times V2, 12.6 liters, divided by P1, which is 1,023.6 millimeters of mercury. Millimeters of mercury cancel each other out. Plug this into our calculator, and we get 20.3 And there you go. We have now done a sample problem for each of the four variables in the equation for Boyle's law. Thank you and have a good day.